Hey everyone, how are we doing? I see the first question today is how many chances do we get on the homework? You have unlimited chances on the Stats 1 homework until the test comes up. Until the test comes up, you have unlimited chances. And there's another great question here to start on the visualization number 2. We can go back over there here in a little bit. Let me see right here. And thank you so much for everyone being here. I've got a video right now. We covered visualization 2. Last week we did a whole big thing on it. We can circle back around to it. I'm trying to find that video. Here it is, visualization 2. Oh, there, I'm talking about visualization 2. So let's see. Who's all here in the chat? Let's wake up Mubot. I don't know if Mubot's awake right now. I think we're streaming. No one said hey yet, so maybe we're not streaming. So Chloe was asking about visualization number 2. Destiny, good to see you here, Destiny. So this should bring you to, good to see your HCT. Matthew's asking about 320. If you have a 320 question, let me know. I think Tiffany's got a question about one of the stem and lease. Yeah, we're just doing everything right here. Chloe, good to see you here. Tiffany and Matthew, good to see your HCT. What's up, Colin? Aw, thank you, Colin. Colin's here. Colin, I saw you called again. I'm sorry. You and I are playing phone tag right now. Wait. They send home the critical care and ABX doing SQ fluids. Okay. Nice. Our bunny is visiting the vet today, and I'll be picking him up. So our bunny has had a vet visit. He's doing all right. He had the sniffles. We don't want him to have the sniffles because he's an obligate nasal breather. He has to breathe through his nose. He's obligated to breathe through his nose. But yeah. Colin, have you seen the new intro? Let's get, I think we're going to, Tiffany had the first question here. The question is, Center for Education Statistics report average mathematical scores for 8th graders of 22 nations. How do you find the standard deviation of the distribution? Let's start that question right after this intro. I'm going to get the question up and going. We'll be right back here after these messages. One moment. I was so close to getting it ready. And so Demetrius, great question. Demetrius asking about visualization number 2. Let me copy the link address again. Save as. I don't want to save as. I want to copy the link address. Demetrius, here you go. There's the... Why is it doing that? Why are things doing the things they're doing? Copy video at current time. Visualization number 2. We go that in great detail right there. We're looking for the question. New topic here. New topic. Oh, got some big news this morning. Tell us, are you allowed to tell us or tag him it? Are you allowed to tell us the big news on here, Colin? We're finding Tiffany's question right here to start. You're welcome, Demetrius, anytime. We're finding the one about the students. I could look over here, but I'm so blind. This is all the questions. Here we go. We found it. We found the one with a Center for Education Statistics reported average mathematical achievement scores for the 8th graders in 22 nations. The average scores for each nation are given below. So one thing you'll notice right here is that these scores are in order. Now I want to point something out, something that makes this question a little bit easier if you get the quiz version. Oh, that's awesome. Oh yeah. Okay, we'll keep on the DL right there. Awesome, Colin. So if you notice right here, I would actually, if you get the quiz version of this, go to the very last part of it because there are 22 nations. If there's 22 nations, I want you to cut 22 nations into 2 parts. I want you to make like a higher nations and a lower nations, like the higher numbers and lower numbers. Cut 22 into 2 parts. How many do you have? Cut 22 into 2 parts. Cut 22 into 2 parts. This is how to solve this problem really well. Cut 22 into 2 like evenly sized groups. Take your 22 nations and be like, what do you get? Great job right there, 11. So now 11, if we have the number 11, 11 is like the lower amount, like 1, 2, or the higher amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the lower. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is the upper. So what if we cut 11 and a half again? Well, 11 cut in half again would mean we're actually going to the sixth number. And what do I mean by this? If you have 11 things, think about what the middle one would be. So my head, got to go this way. I have 11 things if my head is one of the numbers. So my head is number what right now? I have 11 things. I'm holding up 10 fingers and my head is also a number. So you might think it's 5.5, but think about my head. My head is the middle thing right now, right? It's the what number. So my head is the what number right now with 11 things because I have 10 fingers held up and my head's one of the numbers too. So my head is the what number right here. So it's not 5.5 exactly. My head is the what number with 11 things right here. I've got 10 fingers and my head being this. It's the 6 because you would just go like 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6. Sorry. 6 right here being my head. So think about this. 1, 2, 3, 4, 5, 6. Of the lower 11, that's the bottom right there. Does that make sense? Great job there, Giovanni. And then of the upper, what is the middle of the upper 11? Like if you go to the upper 11 right here, what is the middle one of the upper 11? What is the middle number of the upper 11? Like if you went to the top 11 and you said, well, let's go 6 in on the upper 11, what would be the middle number on the upper 11 up there, which is the 75th percentile? We've basically taken the top portion of the data and found the middle of it, and the bottom portion of the data and found the middle of it, which is the 25th and the 75th percentiles respectively. What is the middle of that? What is the sixth number? Because you're just saying, okay, we have the top portion of the data, and it might make more sense if I draw this. Let me go over here and draw on it. I'm talking about the top 11 numbers right here. That's not 11 quite. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the 11th, with the top 11 right here, if we go in 6 numbers, what do we get if we go in 6 numbers right here? What do we get if we go in 6 numbers? We're getting the middle of it. Just like if you take the bottom 11, here's the bottom 11. And if you go in 6 numbers, 1, 2, 3, 4, 5, 6, here's the middle of the bottom 11. That's the median of the bottom 11. It's just that wraps around the screen. It's a little harder to see for that. But does that make sense right there, Tiffany, that that's the middle of the top 11, i.e. the 75th percentile? Because it's the top 50%, and it goes from 50 to 100%. So we're getting the 75th percentile, which is in the middle. So we're actually just kind of visually figuring this one out rather than doing it in the calculator. Does that make sense right there, Tiffany? How are we doing on that one? Awesome. So that's the 75th percentile right there. 1, 2, 3, 4, 5, 6. And so that right here is going to be 518, 1, 2, 3, 4, 5, 6, and this is 388. So the 5-number summary is going to be the min, the Q1, the median, the Q3, and the max right here. These are the 5 numbers we have right here, and the median is the middle number. So to find the middle number with 22 numbers, we need to do the following formula. We need to take 22 plus 1 and divide by 2. Now this tells us the position of the middle number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. So this would be 431. 431. The minimum number is 222. The maximum number is 612. We should be right there. Now, how do we find the IQR? You remember what the IQR is? The IQR is the distance that Q3 is away from Q1. It stands for the interquarters range. So here's the middle 50%, going from 388 to 518. How do we find out what the IQR is? How do we figure out the IQR for this? The IQR is going to be the distance these two numbers away. It's like the range, but only the range for these two numbers right here, 388 to 518. Where the range is just the biggest number minus the smallest number, the IQR is found by how? Think about how the IQR, the range of the middle 50%, is found. How do we get the range of the middle 50%? Not the range of the full data set, but the range of the middle 50. So the middle 50 goes from the 20, exactly right there, 518, which is the 75th percentile, minus 388. And that's the range of the middle 50. So that is just this number minus this number. Now, the mean of the distribution, we're actually going to use jump for this. Now, I do want to point something out. The jump output's a little bit wrong, so don't rely on the jump output for the 5-number summary. I'm copying this to clipboard right here. I'm going to copy it. Command C or Control C, Mac or PC. We're going to go to a jump data sheet, and on the jump data sheet, we're going to go to a File, New Data Table. On a Mac, this will be up at the very top. On a PC, it's at the top of any jump window. File, New Data Table. I'm going to go here to Edit and Paste. That's Edit and Paste. Once we paste in the data, we can then go to Analyze and Distribution, where you can pause the video at any time. So we're going to go here to Analyze Distribution to do a univariate analysis and make the histogram and find the mean and standard deviation. So we're going to double click this variable. Click, click. It goes in here into the Y variable of interest. And then we're going to click OK. And yes, we've got it. So here's our data right here. You can see all the data points. And we can see the mean is 446.55. That rounds up to 55. Or it's going to round to 446.5. So the mean is 446.5. Oh my gosh, what have I done? And the standard deviation is 96.6. And that's, you would not be able, I would not figure this out without a calculator. We could do our trick. It's not that, is it normal-ish? It would not be fun figuring this out without a calculator. I would not figure this out. It's normal-ish. So you could try our trick where we said the standard deviation is usually 1/6 of the length, about. You could try this trick right here, and it's not that close to it this time. It's not that close. It's maybe because that's a pretty low outlier down here. No, it's almost an outlier. But the next lowest observation. But that trick doesn't work. Awesome. Anytime. Yeah, put it in the chat. I think we're going to do a little more 320 or 201, excuse me. So now here's the question. Is the distribution of average math score achievement skewed or symmetric? Okay, let's look at the mean and the median. Oof. There's the median. Here's the mean. Do you think they're approximately equal? Oh, I hate to get one wrong to start out the day. So we have right here, it's symmetric because they're approximately equal. Well, if they're skewed, they would not be approximate. Go over visualization. We did some, we can put that in the chat here. We've got the link to it. Maybe still, let me check. Nope, we don't have the link. I'll check right here, DK. I'll put that in the chat. We might circle back around to it. Copy video at certain time. Here you go, DK right there. There's the link to visualization 2. I'm thinking this is going to be it. You're welcome. And we'll be doing more questions here. Do not worry. I think, oh my gosh. Did I get one wrong? Really? I need more coffee. I need more coffee today. Really? That's skewed? Let me look at the jump statistic on that. Let me look at the jump statistic. What does jump say for the skew on this? Watch it have negative skew. Watch it have... I know, Brian can't math. Oh, what does jump say for the skewness of it? Tell me if you get that one wrong, I'll correct it. If you get that one wrong, I'll correct it. If I get something wrong like that and I'm really not happy about it, I'll correct it. So if you got that question wrong and you're watching this right now and you're like, yeah, I got that one wrong. That was the one I got wrong. I'll correct it. Just, hey, Brian, I got that one wrong. I'll go in and correct it. This is mostly symmetric with a tiny bit of negative skew. Even though the mean is higher than the median, the skew being negative tells us there's a little pull, and you really see it down here in the tail. But the mean is higher than the median. It's mostly symmetric. It's a weird one. Do you have videos for every assignment or only if people ask? If you ask, yep, that's there. I have a lot of things I've done in the past, so you can usually find me working a problem. But if you say like, hey, Brian, how do you find the skew and jump? The skew and jump is found by customizing the summary statistics. If you go to customize summary statistics, you can add in the skew. And if it's negative, it's left skew. If it's positive, it's right skew. And if it's 0, it's more symmetric. I still stand by this is more symmetric. It's just, it's where statisticians would have debates. And it's the problem of static multiple choice questions. But yeah, it's funny. Some of the earlier questions are some of the toughest ones because it's like these iffy questions. Next question. Let's do another question. So I think was there some more 201s? I think Tiffany might have another one. The stem and leaf plot showing the population of 51 regions. We'll do that one next here. The stem and leaf plot, population of 51 regions. Here we go. We got it. Let's go check this out. New topic. Next topic. Stem and leaf plots. Next topic. Now, this one tricks a lot of people because a lot of people think this is what's skew. Now, I want you to tell me what way this is skewed because this tricks a lot of people. I've already gotten a few emails about this one where people said, wait a minute. I know my skew. There's a few. And this is right skew. This is right skew because what's our saying? Right to the high, left to the low, whatever way the tail goes. And someone's saying, Brian, I know that is a left skew. You're still getting it wrong. My Pearson's wrong on these again. Well, the problem is, which what a lot of people will do with this, is when you go and you drop this down, the number line is actually reversed. Now you're like, that's left skew, right? I know it. I told you. See, Brian? Haha, you're wrong. No. Brian's not wrong on this. Not today on this one. The number line's actually reversed right here, and we have to flip it. And now you can tell it's right skew because it's right to the high. The number line needs to go from smallest to largest numbers. Yeah, Kiana, definitely. I think that might be our next one. People were asking about 320. Wait, was there one? I don't think. And then we could redo some visualization stuff here again, maybe. If I have a good video going over, like a really strong video, I try to do as many new topics as we can. You got it. Great question right there, Kiana. So this is right skew right here. That is right skew. What measures of center and spread would be appropriate? Okay, so this right here is very important. We just said that it is right skewed. Since it is right skewed, what measures of center and spread are appropriate? These are things we need to know like that. Since we said it is right skew, what measure of center and spread are appropriate? Great job, Madison. We haven't even thrown points out. Madison, 50 points right there. Madison, thank you so much. The median for the center and also the spread for the IQR. So whenever you say median, which is based on percentile, you'll also say IQR, and this is for skewed data. The first thing you look at is the shape, then you look at the center and spread appropriate for those, and we're going to go with the median and IQR are the best statistics for center and spread respectively. Without doing any calculations, which must be larger, and what follows the skew? Does the mean follow the skew or the median follow the skew? This is a good note to have. Like, people ask me a lot of times, what do I need to know? Like, this class is 2 ADD. And I say, well, yeah, it is ADD. What'd you have for lunch? Does the mean follow the skew or does the median follow the skew? Does the mean follow the skew or does the median follow the skew? Which of those gets pulled by the skew in a direction? We do have that here in the notes. Outliers will impact the mean. So the mean will follow the skew. So since this is right skew, great job right there. The mean will follow the skew. The mean will follow the skew. So the mean will be larger because it's right skew. So the mean's going to get pulled in the direction of the skew. So whenever something is pulled in a direction, the mean will just be like, I'm just going to go with the flow. And the median's like, I'm just going to hang out here in the middle. The median does not move when there's skew. The mean will move when there's skew. Like if the data is pulled up, think about this data point moving further away. It's not going to change if this is the middle number here. It's about the middle. Then this data point will not change the middle number, but it will increase the mean, which is the average of all the values. So we are going to have to find the median and the IQR for this data set. So with this data set right here, can we copy it? Copy to clipboard? Oh my gosh, so beautiful. Amazing. We have this now. Now that we have the data copied to the clipboard, let's go over to Jump, our favorite program. Someone's like, no, it's not. I say, yes, it is. And we're going to go over here to Jump, new data table, file, new data table, new data table. Great job, Gianna, Demetrius, DK right there, and Madison. Excellent work. We're going to go to Edit, Paste, no column names because there's no column name up here. And we could do this visually. There's 51. With 51 nations right here, then the what's nation would be the middle number. The formula is the amount plus 1 divided by 2. Oh my gosh. 51 plus 1 divided by 2. There we go. 51 plus 1. Math is hard. Oh, I see what I'm doing. 51 plus 1 divided by 2. Could have done that in my head. 26. The 26th number is the median right there. So that is the middle number of this right here. This is the middle number, the 26th number. So let's go ahead and take this right here and go back and put the median of 26. Now we need to go in and get the IQR. So the IQR right here is going to go the same way, but we're going to go to Analyze Distribution, take our data, put it in, run it, and we actually get the IQR. Does anyone know what the value of the IQR is? Who right now can calculate for 50 points the value of the IQR? Be very careful. There's a lot of numbers on the screen. We see the 5-number summary with the min, the Q1, the median, the Q3, and the max. And what is DK? Great job. And you can check your mathematics. It's 9 minus 3, which is the IQR. 50 points we said, right? Great job. And so let's go here to customize summary statistics. We can put the IQR right here, and it's just 9 minus 3, which is 6. So 9 and 3 are the 75th and 25th percentile, respectively. So let's go here. The IQR is 9 minus 3, which is 6. Write a few sentences describing the distribution. Not today, my Pearson. Not today. We're not going to let you trick us. The distribution of populations of the regions are unimodal and skewed to the right. There is one outlier. Don't trick us, my Pearson. Not today. It is unimodal. That's one mode. There is one outlier right there. Check answers. What in the world? What did we do? The median IQR are the best. Good. The mean will be larger than the median because the data are skewed to the right to the high. The median, don't tell me the IQR is wrong. Distribution is unimodal and skewed to the right. There is one outlier. Nowhere there's several outliers. There's one outlier. Oh my gosh. Do you see it? I see it. How did I do that? Who sees the problem? And I don't know why I did that. I see the issue. Brian can't copy numbers is the issue today. If I make one mistake, when it rains, it pours. I don't know why I put, there's not even a 26 in here. There's no 26. There's a 16. There's a 10. There's a 10. There's a 12. There's a 12. There's not even a 20. Did I just like accidentally type a 2? How did that occur? There we go. My gosh. I'm just seeing great job, Joey, right there, and everybody. I was like, what did I do? Double check your answers. Brian can't math. No, it's all the coffee today. I got up early today because our bunny needed to go to the veterinary clinic. So and then the Keurig I think is broken. So I'm drinking like triple shot coffee. Woo! Brian can't math today is true. Yeah. We're never going to forget. Never forget the Brian can't math quote. I think we might do a little 474. Put those questions in the chat. We got a lot of time left right here. So put your questions in the chat because we're going to be working on some more questions. Let's hop back to the main screen. Brian's going to learn how to math right here. Brian will eventually learn how to math. Does this one not have a fade in? What questions are there? Fade in. No, fade in, fade out. Q. We got right here. HTT says Q4 for BAS 474. That was HTT. Was first right there. And what I have, and I need 7C. Wait, 7B. Which class is that? Lindsay was first. Lindsay was first. 7B. For which class, Lindsay? 320 or 474. Brian's going to wake up. Wake up, Brian. 320 or 474. It's right here. I think I have both homework assignments open. 8C. Oh man, 320, 474, ready to go. I say, let's go. 7C for which class? Lindsay was first right here, so we'll do Lindsay's question first. 7B, Lindsay said. 320, 7B. Let's go check out some 327B. Next question, 320, 7B. Let's go check this out. New topic. New topic right here. And we'll keep doing some more right here. We'll work on this for another 20, 30 minutes here. So stay tuned. 320 and 474. New topic. 7B. So in this one, we need to make a subset. Now, I'm not going to do the full subset here. I want you to work through this a little bit and make a subset. To make a subset, we store into sub. And then we want to take... See, I've got a subset over here. We want to take a subset and store into this from the alumni data frame. And now what will this create? I've already created it correctly if you can't tell. So this will now create a subset of the full data frame. So if you have the subset, oh my gosh, what's going on right here? So we have the full data frame subset. Calm down there, Google. And with this right here, we need to then put in some conditions. Now, this is not what you're doing. Once again, Brian works similar problems. This is the condition portion. Let me go to my subset and look at this. I want to do degree 1 major. Let's go to degree 1 major. I'm going to do this right here. And I'm only going to take, let's be very careful. I'm only going to take people who have a major contained in statistics, if I knew how to spell, or finance. Statistics, good. Okay, this is not your question. And now we have a smaller subset. Let's go look at degree 1 major. And there we go. Does this make sense right here? And so this is kind of a big hint because I think this condition oftentimes gives people a lot of trouble. So I've kind of written one of the harder conditions. I haven't taken certain rows or certain other variables, but this is kind of a start of it. Lindsay, like, you know what we're doing right here. Like Lindsay and I were sending message on Discord, and this makes sense right here, right? This says only select degree 1 majors that are contained in the vector statistics or finance. So if you go and look at your subset after you do this, you can look at degree 1 major, and you just have people who are statistics or finance. So we only have these majors. Let's throw some 50 points. Everyone following along right here. And so we just have this. So now the question becomes for 7b that we have a subset, not the subset you're going to be using. What fraction, 0 to 1, of these alumni in the subset are statistics majors? Well, how can we write a test right here to see if somebody's major is statistics? How can we write a test right here to see if someone's major is statistics? We could do the hurricane one here in a little bit, Joey. You got it. How could we write a test right here to see if somebody's major is statistics? Like, how could we do that? So now we want to like write a statistical test. Well, we can do the length soon, but think we want to do a logical test. We want to do a logical test. So we want to do some sort of logical test. So what else? What do we need? Nah, DK, you got this. You got this. It's practice. We got data camp and all this good stuff right here. I bet you if you asked people 2 weeks ago, they'd have been like, I have no idea what I'm doing. Now they're like, it's starting to make sense. Can you do the quiz question? Yeah, we can do it here a little bit. Oh, pizzas. We got a visualization 2 video. I might be able to circle back around to that. We had a whole office hours pretty much dedicated to that, so that's why I've been dropping this link in the chat. So Giovanni right here, I've got a whole video on that right here. We could circle back to that, but that one goes over pretty in depth, like each step, and it's already labeled too, so it's got each part. But I might circle back around to visualization 2. Since I did a whole office hours on that, I probably will come back to it. I don't know. Well, how can we do a test on this to see if like something is logically equals to something? So how do we do a logical equals test? So think logical equals. Just think about just putting that in the chat right now. Logical equals. How do we do a logical equals? How do we do a logical equals? Like we want to see like, is this logically equal to this? No more coffee now. How do we do a logical equals? I think Colin got just cast as the new Captain America or something. I wonder. Said he had big news. How do we... You got it, Lindsay. Great job right there. Oh, I'm not on... I need to go to live chat. Sorry, I'm on live chat now. I forget. YouTube defaults to top chat, which is not good. So let's go here to the sub, and let's go to degree 1 major. And in degree 1 major... I'm going to see if someone's degree major is equal to finance. And this gives me trues and false. Oh my gosh, don't do that. I'm going to see if it's equals to finance. And this gives me trues and falses. So what would the following give me right here? What does this first line of code do right here? You're welcome, Giovanni. Thank you so much. What does that first line of code on 210 do? Think about this. Trues and falses are 1s and 0s. So if I take the mean of a vector, true, 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 false, 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 it's going to give me 50% or 0.5. Why? What does mean do when I give it a logical condition? So what does mean do? It tells me the percent of what's. If I put a logical vector inside of means, it'll tell me the proportion of them that are what? I need a disclaimer that I put in the corner that says, like, Brian works similar problems. I'm going to make that this weekend. Exactly. Well, and it's telling me the percent of truths. Does that make sense? So it's telling me the percent of truths because truths are ones and zero, or truths and falses are ones and zeros. So I can do the mean of a logical vector and find out what percent of this subset are finance majors, or like 91%, or I can find out how many of them are finance majors. Exactly. Does that make sense right there, Lindsay? Like, if you take the sum of a logical, it tells you how many truths there are, like how many people meet this condition or how many things meet this condition. If you do the mean of a logical, it's what percent meet this condition. So you can just take a logical vector and throw it inside of a mean and be like, well, what percent meet this condition? Just put it inside of a mean, and then you can find out pretty quickly. You can do it a much longer way, which I don't suggest. I do not suggest this. The long way to do it is going and doing length, which, this, and then n row sub. You will get the same thing as the mean. It's just a much longer way of doing it. I do not suggest way number 3. Not the sum one. And you could do the sum and then divide the sum by the n row of sub, and you should get the same answer too. So there's a lot of ways to do this right here, and just thinking about what you get, like, do you want how many or the percent? And the mean's just a quicker way of doing it. Does that make sense for this one, Lindsay, right here? Like, I didn't do the exact question, but how are you doing on getting yours to work to figure out, I think, because it's very, very close to what I did, like the fraction that are statistics majors. I think you should be pretty good on that. And then we could look at sorting something. We'll look at the last one right here for 7C. Let me just call this question 7 in the video. To sort a data frame, you have to use the order function. The order is going to return the order by which things should be reported. Awesome job there, Lindsay. And so we want to order by the vector. Sure, let's go log lifetime gift to UT. So this is the order by which it should be reported. And now I like to call this positions right here. Awesome. So I'm going to call this positions right here. And in my subset, I'm only going to take a few things. I'm going to take, oh my gosh, zip code. I'm going to go select equals zip code. And the other one. There we go. So now I only have 2 vectors. Oh no, I need degree 1 major also, because these codes won't work. Not that I need to run this again. Okay. So now I only have those 3 columns in there. So the select argument only takes certain columns. So I started a new argument with the comma, and then I'm selecting just those columns by saying select this column, this column, this column, and this has to be put into a vector to say select these columns, and you have to put the columns into a vector. So now when I order this, I want to store these as positions. This is the way I like to do it, just in a few steps. And I'm storing a vector of positions that's going to order the data frame for me. So I'm going to go to my subset I've created, and I'm going to call positions into the rows. And then let's go right here and store this into sub2. I think you call it something different. But if you take a look at this subset, what do you notice? Well, the lifetime gifts to UT are not from biggest to smallest. That's because I need an additional argument right here, and order needs decreasing equals true. And now we take a look. I was wondering, does the test my system count as a grade? I probably won't count as a grade. I might count as a... I'm going to double check with Terry. I might count as a 1 point bonus or something. Maybe I'll do that. I'm going to double check with Terry because it's in an unused category right now. It's just to make sure everything's working. But I might talk to Terry and say, can we do this as a bonus and maybe extend it a little bit to make sure everyone turns it in? But that way you know your system's working, so when we get to the test, there's no issues. Because it's not good when there's issues on the test day. But it's a really quick thing to do, test your system, make sure it's working. But does this make sense right here? And great question, Tiffany. Thank you so much, Tiffany. 50 points right there. How's this look right here on coding this? I've kind of done a good bit of it. How many points does it take to get to 1.2? A lot. Can you help with standard deviation out there? Yeah, let's do let's do one more 201 problem. Hannah, do you want it? We'll switch back and we'll do a 201, then we'll do a 474. Which 201 do you want to do here, Hannah? Which question do you want? Let's go back to the main screen here. That was question 7 for 320. And then Matthew will do that one next. Still kind of confused on that. Awesome. That helped a lot right here. Awesome. Which quiz 2 question are you working on, Hannah? Which quiz 2 question are you working on? 7C is tough. Yep. And you got it done, Matthew? If you got it done, Matthew, great job. That one is a little bit weird code. We talked about it a little bit during class today, but that was one of the tougher ones to code. So think about how your code looks and the variables you're using, and it'll be very similar. I like to do it in parts. And then we'll come back and we'll do 2C here probably quick. What does your question 2 say? Because there's a bunch of different ones. So because question 2 can be many different things. So you can tell me what the question 2 says, and I'll take a look, and we'll do that right here. Let's see, and then we're going to do some more 32474. If you can tell me the start of the question, like does it say students in a class or a pizza place? Just tell me the start of the question, and then I'm close. The last question is where I'm hung up a bit. Oh, Matthew, you're doing a great job right there. How do you then print the rows? Use head. Use a head data frame if it wants to do like the first 6. Or you can do that. Yeah, you want to do rows 3 through 6. So do like sub square bracket 3:6 comma. Make sure there's a comma because it's 2-dimensional. Center for Education Statistics, you got it. The quick question, the histogram shows the distribution of the right pierces, pizza places. Yeah, let's do it. We'll do Hannah's, then we'll do Matthew's, and then we'll do, was it Matthew had one? Matthew had, okay, so we're going to do, remind me this order. Hannah's, Matthew's, Tiffany's. Let's do this. Here we go. Hopping in with this center. And thank you so much, everybody. All the positivity. And I love that we have so many people here. That's the way it goes. 2C should be real quick. You got it. Coming up right next after this one. So the center... Where's the center one? The Center for Education Statistics. I'm finding it right now as we speak. We did this one at the start. So Hannah, check it out. We did this one at the very start of the class today, or the start of the office hours. So Hannah, check that out. I think Tiffany asked about that one. So we're gonna jump to Matthew's question because we did this one at the start, and we go through and show how to use jump to get the standard deviation, and we did the 5-number summary. So if there's a little timeline down here, and if you scroll it backwards, you'll see me work this problem from start to finish. Yeah, thank you so much, Hannah. Awesome work right there. If you're stuck on another one, let me know. And then hopefully, no, but Hannah, I'm throwing Hannah some 50 points. Hannah throwing some positivity right there with some okay in the chat. I appreciate it so much. And thank you, everybody. Sometimes I'll do a question like 3 times in a row. I'll forget. I'll be like, wait, I did this. I'll forget. That one, wait, is that the one where I got the one thing wrong? I didn't get anything wrong. Pretend didn't happen. Let's hop here to Matthew's questions. Thank you. Let's hop in here to 2C. Here we go. New topic, 2C. Matthew's question, new topic, 2C. Let's do this. Okay. You're welcome. You're welcome. Thank you, Lindsay. Let's hop over here to some 2C. Okay. Consider a sequence that starts. A sequence like, not starts, but a sequence from. I don't like saying start. I like to say a sequence from. What do you think we should change this to? Not a sequence from 5 that goes whatever. Like, let's just say a sequence from 5, and let's throw a word in there. What's a much easier way to say this? I might just do this one. I feel nice. Sometimes I do the question. Sometimes I do a similar one. Always watch out. Sometimes I do similar things. Sometimes I do the exact question. Be thinking, is this what it asks? Is Brian doing exactly what that question asks? What do you think is a better word? Consider a sequence from 5. Let's take a look at the sequence documentation, see if it has helpful hints on how we should be doing this right here. So let's go question mark sequence, which is I don't want sequence to binomial. Let's go question mark sequence, which is a great thing right here to look at how the sequence, boom, right there, got some 2 in the chat. That's worth some 20 points right there. And it changes, of course. We're going to go 2, and then this has, and let's go length. So we're changing it to the names of the arguments. It just is nicer right here. So from 2, and then there's an argument length out, but that works as length. So let's just go right here and create the sequence with this. Sequence from equals 5. We're just naming that argument. 2 equals 8 by length equals 121. Does that look like we've created what we want? How's that looking right there? I think that looks pretty good. That looks like a sequence with 121 elements because this is the 118th, 19th, 20th, 121st element. It starts at 5, as we can see right here, and it goes to 8. And you know what we can do? We can make our lives easier by storing this into X. And you see I just store tons of things into X. So we have right here, X is a sequence that goes from 5 to 8 by 121. You can always highlight code to run it. So you can just run individual portions by hitting Control or Command Enter. How many elements are greater than 7.13? So all I want you to do, Matthew, right now is I want you to just write this part of the code. And you'll see how this has overlap with the question we just did. So I want you to just write the code to see if something is greater than 7.13. So pretend you have everything I've written out that I've written out, and just write the code that would test to see if something is greater than 7.13. So only write that. Oh, use the one like, oh, that's, I think Matthew's got it right now. So how would we do this test to see if something's greater than? How would we do the test to see if something is greater than? How would we test to see if something is greater than 7.13? Look, we just have all these values right here. Let's see if they're greater than 7.13. How would we do that? What code would we write to see if it's greater than? How would we do a logical test to see if something is greater than... that'd be greater than or equal to. Great job right there, Lindsay, 20 points. That'd be greater than or equal to. So we just want greater than, and you might get the same number. It looks like you will. We're just going to do 7.13, and that is trues and falses. How are trues and falses seen inside of R? How are trues and falses seen inside of R? Trues and falses inside of R are seen as what's and what's. Trues and falses are seen as what's and what's inside of R. Very important thing to know, that R just sees these as what's and what's. A false is 0. Great job right there, Kiana. Zeros and ones. It sees them as zeros and ones. So how about we just find out how many there are, or we find out what percent there are. So we can find out that there's 28.95% that are greater than this, or we can find out there's 35 values that are greater than this. Does that make... I kind of just worked this one, Matthew. And do you see the similarities between Lindsay's question we did a moment ago? We're doing kind of the same sort of work right here where we're doing a logical test, and then we're finding out, well, how many things meet this logical test, or what percent meet this logical test. Awesome. My class will end right in time. Go pick up Morty. He's had a rough day. When I brought Morty to the vet, he was thumping. Rabbits thump when they're like angry or in danger. And he's just in the back of his little carrier and just going like, thump, thump. Oh, it's all right, Matthew. No worries. No worries. We'll hop over here to the main screen. You're welcome there. Is there a lot of coding layer stat classes? Because I low-key want to minor in stats. It all depends. We have a lot of different classes. Can we see Morty? Yeah, we'll do a little quick Morty view right here. There's different codings per class. Some classes, like Charlie's Quick classes, uses Jump, which we use in 201. We have some classes that use Python. We have some classes that use R. We have some classes that use SQL. So not a ton of SQL. We need more SQL. That's actually one of the things we talk about is we need more SQL. But I would say it helps be a good coder. Not required, but the better coder you are, the better. It's a great skill to have. Here you go. Here's Morty real quick. He's our TA if you didn't know. SQL is fun in INMT. Yes, 341, 342, right? Here's Morty. Let's go back to the main screen. He's so cute. He's such a cute bunny. Okay, the question was, I think the next question was a 320 question, and then we're kind of open, so we need to put some more 474, 320 after this, definitely. Tiffany had the question, can you do the question, the histogram to the right shows the distribution of prices of a small pizza of 360 weeks in a large city. A small pizza? I'd like a small pizza right now. Maybe we'll have pizza tonight, you know? Oh my gosh, I got it. First try. Let's go take a look here. New topic, visualization 3. Ooh, we could do some visualization 3. We'll do a little 474, then let's hop back and do some visualization 3. I think that'd be a good idea, Olivia, right there. And Kiana wants 474 8C. We'll do that next right here. Then we might do another 474. I think that'd be good. Kind of doing different things for each class. And then we can start doing maybe some visualization 3. Let's go check out new topic, small pizza place for 201, new topic. So here we are, a small pizza place. I wonder what kind of pizza it is. In a large city, New York City, for 308 weeks. So we want to look at where the mean is at. Now, the mean is kind of the balancing point. Now, one thing that people often get a little bit confused on here is what's the difference between the balancing point and splitting the histogram into two areas. So when we look at the mean, it's probably about 2.20. That's the price of a pizza? Where is Ma Pearson going and getting a small pizza for $2.20? You could literally go get a small pizza and a Coke for under $3. No one's getting small pizza and Coke for $3. I don't care. It's 2021. Ma Pearson, what year are you in? So we have right here, the mean is close to $2.20. It's kind of the average of the distribution, which is the balancing point. What would split the histogram into two parts where you have like the top 50 and the lower 50? What concept? They do have secret locations, it seems. What concept splits the data into two halves? What is the middle number? Hint, that is the 50th percentile that splits it into a lower and an upper portion, which would be splitting it into two equal areas. What would that be? That's not the mean that splits it into two equal portions. The mean doesn't split it into two equal portions. The what does? So the mean wouldn't split it into two equal portions. The what would? Because the mean's kind of a balancing point, like a 50-50 balancing point. What would split it into two equal portions? Not the mean. The median. The median would. Great job right there, Olivia, 20 points. The median would split it into two equal portions. And so the mean is kind of a balancing point between the two of these. Now, the standard deviation is a bit of a tricky one. Now, the standard deviation we have a trick for. And our trick is this. If the data looks kind of normal, we can take the higher number up here, which is 2.7. That goes to 2.7. And take the length of this. And we did this in class at the very, very end. And we can divide this by what? What can we divide this by to get an estimate of the standard deviation? An estimate of the standard deviation is to take the range of the values, and this is just an estimate. It's not literally how you find it. It just it'll give you a guess of it. And this one's a very good guess. You take the length of the values, and you divide the length of the values by what? So you take the length of the values, and you divide the length of the values by what? To get an estimate of the standard deviation, take the maximum and the minimum number, and if it's normally distributed, like is a bell-shaped curve like this, if you take the distance of these two numbers, the min and the max, and you divide by 6, then you get an estimate of the standard deviation. Not saying it will be it. Let's find out what the estimate is. That's interesting. The estimate of the standard deviation is 0.15. It's just a good estimate. And we should have it. Oh, wait. We got to check that answer. And that's got it. There we go. I was like, I'm not going to get another thing wrong today. Not today, my Pearson. But that's got it. Does that make sense right here? The mean is the balancing point of the distribution, and the standard deviation is a measure of spread. And why are we using the mean and standard deviation right here? Who can explain why we are using the mean and the standard deviation? Why are we using the mean and the standard deviation? It's just kind of a, I guess, heuristic. It's just kind of how it works. It's not literally a mathematical equation. It's just an estimate to say it's about 1/6 of the way. Awesome job, Hannah. Great work. So we're using the mean and standard deviation because the data looks kind of normal. If you look at the shape of the data, it looks kind of normal. And look at the shape right here. The shape tells us that we should be using the mean and the standard deviation. And that's what we're going to use to start out with, because the data looks pretty unimodal symmetric, and the more symmetric it is, the more likely we are to, the more appropriate it is to use the mean and the standard deviation. I think that's got it. I think there was a question, 4748C. Does that make sense there, Tiffany? We're dividing by 6 just because it's just a good estimate. It just gives a decent estimate of it. If you notice, if we were to go out, usually go up and down. Yeah, so the way it works is when we have normally distributed data, which we'll see a lot of this in chapter 5. If anyone's taken 201, then they know the empirical rule. The empirical rule states that when you take your data, if you go up and down 3 standard deviations, for the first standard deviation, which is just 1 standard deviation away, you will see 68% of your data. That's 1 standard deviation. 2 standard deviations is 95, 68, 95. And someone's saying it before I even say it. The next standard deviation, which I drew so poorly today, that's because I didn't draw the 2 standard deviation line. The next one is 99.7. Hey, what's up, Brendan, right there? I need some help with assignment 1. Have you gotten over questions 5 and 7? I think we just did 7 earlier, right? We just did 7 earlier in this video. Check that out. We're about to do a 474, but check out, we just did 7 earlier, a little bit talking about the subsetting one. So great question, Brendan. Excellent work right there. So this encompasses pretty much all the data. And what are we doing? We're going up 1, 2, 3, and we're going down 1, 2, 3 standard deviations, which is a total of 6 standard deviations. So that's the standard deviation mark right there. What's up, Justin? Good to see you here. Quick question. I was watching charts yesterday, and I was following along with question 9b, and I think I understand, but I'm not sure what to print to the screen. 9b for 474 is the recoding of the vector. I think you want to show the vector in its original format. So show the vector in its original format. Great question right there, Cora. Excellent work, everybody. Let's hop back to the main screen. We have the 474 question from Kiana. New topic, 474, 8C. 474, 8C. Let's go check that out. Here we go. 474, new topic, 8C. Here we go. And so let's go to 8C down here at the bottom. 474, 8C. Oh, a lot of work from earlier today. And is this 8? Oh, we were talking about 8C earlier today. So 8C is the conditions in 474. Should I be able to print? Yep. You should be able to print them in their original form, I believe. So you should be able to untransform them, I believe. When we do the question C right here, we'll do one of them right now. What we have right here is we have conditions on the price vector. So when we look at these conditions right here, you're welcome, Cora. Excellent work on 8C right here. I'm just putting in my own chunk so I can go back to it. With this chunk right here, we are checking to see if the price right here, oh, I don't have it loaded in. Let's load in the data. So I ran all chunks above right there. We're going to go right here, and the value in low needs to be less than or equal to the value in high. Now, what do we have right here? Is this, if it meets, great job, Tiffany, excellent work, congratulations, great work right there. Is this something that meets the condition or violates the condition? Does this meet the condition? It says the value in low should be less than or equal to the value in high, violated when low is greater than high. So I wrote a condition right here. The value in low is less than or equal to the value in high. And this is like what people are bidding on, the low bid price and the high bid price. We're doing validation right here to make sure this data is correct. Like, well, we shouldn't have a higher low price than we do high, so the value in low should be less than or equal to the value in high. Is this something that passes the condition or fails the condition right here, the way I've written this? Is this passing the condition or failing the condition? What do you think? I'm checking the value in low and seeing if it's less than or equal to the value in high. Is this passing or failing the condition? The way I've written this is something that passes. So how about if I just take all of this and put a 1 in front of it to flip it? Because we don't want things that pass the condition. We want things that fail the condition. And 320, if you remember, great job, Justin, right there. Justin and Kiana, 50 points, both of you combined together right there. You're 100% right. We want something that fails the condition. So I put an exclamation. And then guess what I can do? I can find out how many things fail the condition, or I can find out what percent. Now, it is saying NA because there are NAs. So we got a problem here. We want to go to a second part of this and do NA.remove equals true. And that's a new argument we're including because there are NAs here. And now we see that nothing fails the condition and also nothing, 0% fail the condition. The first 0 means there are none because we're summing up all the things that fail the condition. The first 0 is how many things fail the condition? None. The second 0 is what percent fail the condition, and 0% fail the condition. So be careful on which one you use here. But is this making some more sense? Hey, what's up? It's our doctor friend from across the pond. How are you doing? Hope you're having a good day right here. We're working away doing some more validation of data. Maybe we'll get to see some shiny in time series data. You never know. What questions are there on this one right here? Is this making more sense, Kiana? Then you want to go through and write additional conditions and additional things to write the next few conditions. So we're just seeing like a logical test right here. And then we're saying which things do not meet the logical test. And then we have right here the sum of the things that do not meet the logical test. Because this vector contains NAs, we have to remove the NAs to do a sum. It's just the way the sum function works. It requires the additional argument. I think that's got it. We might do some visualization 3. Should we do 32474? Let's take at least one more question from 32474. 32474, it's your turn to ask a question or two more. And is that for 32474? Justin, tell me in the chat here. A little chill music. I think it's morning, but should we show a friend from across the pond the new effect? Let's do the new effect for the semester while Justin tells us. Just having too much fun. Let's go here. New topic. 474, new topic. 474. Let's check it out. New effects. Always new effects here on Stat 201. Let's do some 474, everyone. Let's do this. I'm having too much fun. Brian, you're having too much fun. I broke my R with that. What did I do? So 2 seconds here, everybody. I literally broke my R. Let me close out of R. Does that cause an issue? Does that do a hotkey that breaks R? Oh, I can't do that effect anymore. I have no idea what that means. Oh, I think I broke my R. Why? Oh, I think it's this button. Show all panes. I fixed my R. Wow.
Wow.
Okay. Here we go. Getting things fixed up. Good to go. New topic. BAS 474 3E. Let's go check it out. BAS 474 3E. Let's jump right to it. And here's question 3. And oof, that's a lot. Let's go to 3E. And 3E says all but the 255th element. So we're going right here. We're taking the box data right here, storing movie box offices into box. And with this right here, do we have it? We don't have it. We need to reload the data frames. Let's load everything above. That loads all chunks above. And then let's go right here and run this. And boom, we're good to go. So now we have it loaded in. We just didn't have the movie data set loaded in. And now we take the vector inside the movie data frame and store it as the vector box right here. So the question is, do we need to find the mean of anything or something? We're going to find the median. So let's first go here. Let's insert a chunk because I like to code where I can see the question. And let's call this Q3E. So now we're going to go to the box vector. That's just a vector. And we're going to report for the box vector everything but the 255th element. Everything but. And there it is. Now, if you go to the 255th element, you'll see it's gone, but it'll still be there because something replaced it. The 255th element was not here. Well, it's not here now because to view it, we'll actually have to see the vector with it. And it is currently value 255 is going to be right here. It's 194.2. Sounds like a radio station. 194.2. Like 194.2. Got to repeat it so you don't forget it. And it is gone. Here's the 253, 254. It's gone. Now, there is a new 255th because we replaced, like, it just kind of, it's gone. But there has to be something, just kind of like takes that out and then everything just crunches in around it. So this is the whole vector with everything but the 255th element. And then all we need to do, because I think we're reporting the median, is go around it and put this right here. Let's go here and do the median. And I think that's got it. As long as there's not NAs, we're good to go. Does that make sense right there, Justin? Is this the one you want to hear? Base was good. Way is good. Are you still avoiding tidy? We should wait. So tell me how to code that in tidy. We were actually talking about tidy some today. Sorry, I'm like all tired here. Have you done 1B? We could do 1B. Base ways. Oh yeah, you're talking about base R. Yeah, base R. Like I was like base. I thought there was like a function in base. But tidy is really good. Tidyverse is really great. We need to do more tidy. Like we have people working with DataCamp and stuff. Hadley Wickham with tidy. Baseway, classic ways of doing it right there. How would you remove? Is there a better way to remove stuff in dplyr like filter? Like there's the filter in dplyr. For 474, how would you put a line of code to return a name like for I? So we've got here 1B. So let's do that one. Whee! New topic right here, 1B 474. And I will say this, our friend from across the pond right here does medical stuff and uses R and has some great knowledge for a lot of the topics. So love having them here. And it's got to be like, what, 1, 2 a.m. your time? 11 p.m.? I don't know. It's got to be like, what, late? Wait. Yeah, it's got to be later. Box, filter, box, minus. And then, yeah, he's using the piping options right here. Maybe. That might work. Let's check that out. And then we're going to go check out. It might work. It says unexpected minus box. The minus box is having an issue. Oh, the box is capitalized to start. This looks really close. It'd probably work better with the data frame because it's a position. Let me look at one thing real quick and then we'll hop. You didn't know, Andrew? We got visitors from everywhere. Filter position in dplyr. Subset rows using their position slice. We want to slice, it looks like. But we want to slice something out. Slice it out. No, maybe it's not slice. I don't know if it's slice. It's a good question. If we get it working, that'd be interesting. So is it slice? But you have the piping options right there, which is really good. You're piping the vector into a filter and then piping it into the median function. So good stuff right there. Good stuff. And then we have, so the question was 1B 474, new topic, 1B 474. 1B for 474. We could try to do it to dplyr way. Oh, we got this. So I want you to like think about this sequence the following way. I don't want to write this. I'm going to drop some hints right there. I'm sorry, Liam. It all starts over with the mu bucks. Liam, are you taking a class with me right now? I could change your mu bucks. If you're not, I can change them back. If you're like, no, Brian, I have no classes, I can refund your mu bucks. They get thrown back every semester. Let's bring in Mubot for this question.
I am here to help with sequences. How would we write this sequence right here? 1, 2, 3, 4, 5, ... 100. How do we write this sequence? Congratulations! It'll take a while to update, Tiffany, sorry. We've done some. That works right there, Cora. Make sure it has the sequence around it. Cora is correct. Sequence 1, 100, 1. There we go. Also, quickly, 100:1. Same thing right there. Now look at this. Do you see it? What do we need to do now? Go ahead and put it in the chat. I'm not allowed to give the answer. I am evil Mubot. That's looking maybe, but do it in parts. Ashna, very close. We could loop it. I would not suggest that. Someone's gonna do this now. If we went here to, let's just go here to value. I would not suggest a loop. Maybe I'll finish this as Mubot. Variable I, UI, I don't have a UI. Vector 1 through 100, and right here, value is open. Value will be replaced with the value of right here, 1 divided by I, and so we will constantly sum this, so it'll be the sum of, and we need to set value equal to 0 probably then. Value equals to 0, original value, plus the value of 1, and this might work. Oh, I think we've done it. Now the value is set to this. Is that right? No, that is not right. That is not right. Is it? It might be right. I don't know. I'm Mubot. Let's see the right answer. Brian's going to come back for the right answer.
That might be right. Let's find out. Let's go right here. Let's evaluate this first on the bottom. Let's go here to sum. Yeah, that's right. So that's the way to loop it. No, I'm not taking a class with you, unfortunately. Aw. Just making a joke. Couldn't type this at your face. He talks whenever he just joins in. He just talks, you know.
I am Mubot.
He's pissed about things. I don't know.
I am Mubot.
He's happy now. So, it's definitely not me. It's definitely Mubot, just so those didn't know. But right here, this is a few ways of doing it. As long as we have this sequence right here, we can just do 1 divided by. What's really cool is you can take and you can, once again, don't put all this code here. I'm just doing it a few different ways for fun. You're like, coding is fun? I'm like, yes, coding is fun. You can use the fraction function to actually view the fraction. Is it fractions? There we go. It's fractions. So the fractions function lets you view the fractions. And you could actually get this answer right here, not as a decimal, but as a fraction. That's a ridiculous fraction right there. So you can actually get this as a fraction, which if you just report it, it is that number there, which is the same number we see right here, but you can get it reported to you as a fraction. So it's pretty cool right there. I like the different things you can do. I see some 320 questions, and then Ashton had a question about 4i, so let's go do some 4i right there. Oh, you're awesome, man. We always got some Puppet Shark here. And Tiny Puppet Shark. It's awesome. Have you gone over chapter 3? Which one are you wondering about? We've done some, Trevor. Drop a question. We'll try to do that here. Drop one of those in the chat, and we'll do it right here. We might have to do visualization 3 next time. I do have some videos going over the visualizations. I got the visualization playlist, but we can always do in the visualizations. We've been doing a lot of homework. Let's go over to 4i for 474. 4i 474, and then we might do some more 201 here. 4i for 474. 4i for 474. That's the notes from class today. So 4i from 474. What movie has the largest box office haul? I kind of just want to do this one. What movie has the largest box office haul? And so to do this, we want to find the movie with the whattest box office. I'm putting in a chunk right here so I can go back at any time and find this. So what do I need to put right here? Relative frequency question for chapter 3 homework. Cool. Put the start of it. Thank you so much, Trevor, right there, and we'll try to find it. What is he? Mubot. He's trying. Mubot's crazy. We can use which max and we can use max. And you know what I do suggest doing is which max. So which max is going to get us the position of the maximum. Don't worry, Mubot's just being crazy right there. So in the movie data frame, we want the movie with the largest box office haul. So when we go here to box office, we can find out the what of this movie. Now be very careful. The maximum, we can use max. And this is the largest box office haul, which is 3 billion? We'll find the name of this movie in a moment right here. I just got to get a number instead of a movie name. Yeah, we'll do this right here. So what... We're getting the position exactly. So I like to store this. I like to do it as an additional step right here and store with position. And then now we can go here to the movie data frame and put that in the rows. And of course, it's Avatar. Not Avatar: The Last Airbender. It's James Cameron, known for Titanic, the Avatar movie. Apparently $3 billion worldwide, 3.1 billion. That was released in 2009? No way. It just feels like it was released even longer ago than that. I guess so. Makes me start to feel old, right? It just feels more recent then. But Avatar right here has pulled in $3.2 billion. And I don't know if the which function has a second argument. I wish we could pull up the second one. I wish we could. I don't think it's that easy to pull up the second largest. What you could do, if you wanted to get the movies, this is a totally different way of doing this. You could go here to order the movies by the box office, and that's the order right there. I'll go to position 2. This is not the question, but what I want to do right here is I want to create a movie sorted, and this is kind of like some of your other questions where the movie data frame will now be sorted by the positions I've created, and if you view the start of this, then you could actually see, let's go to the head of this. You could actually see the top 6 grossing movies of all time. Oh, these are the lowest grossing because I didn't do reverse. What's up, Tommy Wiseau? Let's go to decreasing. I met Tommy Wiseau one time. Decreasing goes true. Sorry, Tommy, you're gone. And now we see the top movies are Avatar, these movies right here. I had to reverse a range function in tidy way, I think. Yep. Oh, Trevor, that's awesome. Thank you, Trevor, so much. And then ggplot. We've been doing ggplot in 475. So if we have some 475 questions, we will be doing some ggplot. And check out the package ggpubr. Real quick plug for the package ggpubr, which ggpubr has functions like, let's go look at it real quick. It's got some amazing functions like the geom. It's got, not those, gg.plot gg histogram. Because with ggpubr, you can just take, instead of having to write really complicated stuff, you could just go to gg histogram and put inside gg histogram movie $sign box office. And guess what? Boom. There you go. There is a GG histogram. And if you want, do I have Plotly up? GG Plotly. Nope. We need to go, sure, let's go to Plotly. And inside of Plotly, we're going to call the function GG Plotly. And then we're just going to wrap this inside of it. And now we've created a Plotly object within seconds. So ggpubr is a really nice package, part of the tidyverse also. But this is something we're doing in 475 right here. And ggpubr is just a really great package. And we just wrapped this inside of a basically a container that turned this into a Plotly object. So really great stuff right there. If I send you my code for 9B on Discord, can you let me know if I'm the right type? Yeah, Cora, definitely. I'll take a look a little bit later. You got it. I think we had a 320 question, right? A 320. Let me hop back to the main screen. 320 question. If you have time, 474, untransform a list of values. I think we can probably get to that. You bet. Let's try to do that. And which one are you working on, Ashton, right there? There was a 320 question. The 320 question was 320 number 3. 320 number 3. 320 number 3. Here we go. Let me stop the music. New topic. 320 number 3. Question 9A, you bet. And so let's go here to 320 number 3. And we've loaded in some data. And the question says, after loading in the file, you'll see that there's an alumni data frame in there. In the global environment, for questions 3 through 7, remind yourself of the R command that determines how an object is seen inside of R. So what, and this is huge, we need to know this, how does R define how it views things? Which you can kind of see how R views these things here. This is how R views things. So how do we know how R views things? Like you can see that's numeric, that's integer. These are not numeric and integer. They might have numeric or integer things inside of them that has factors. How that's a character. How is it that R views something? How can we tell how R views something? Very important little function we should know. How can we tell how R views something? How do we know how R views something? Very important thing. It's the what of an object. How do we know how R views something? I think you're right about the arrange function. How do we know how R views something? What is the very short function which tells us how R views something? So this is the what of an object. Neighbors like making noise. The what of an object right here is how does R view it? So how does R view these things? Each of these has a different what. Some of them have the same this, like that has the same this as this. This is known as the what of an object inside of R. Like R's got this thing and it says, oh, it has this blank, which is how it handles it. So if it has different this, then it'll use it a different way. We were talking about this in class today where we said, like, if I hand you a ball, the ball could have baseball somethingification. And if you're like, oh, it's a baseball, well, then we throw it, we hit it, we catch it in a glove. These are the ways we handle it. But if it's a basketball, we dribble it, we shoot it, we pass it. Like, you don't say, pass me the baseball. I guess you do. You don't say, shoot the baseball. You say, throw the baseball. You say, throw the basketball. You don't say, hit the basketball. You say, dribble the basketball. So each of these has a different what inside of R. So the way these are seen, so a good question right there. So each of these, like this is a character and that's the blank of the object. This is a factor and that's the way the R sees it. And what do we call that? Each of these has a different somethingification, different, I don't want to say the word. I always like people to think of the word and to be like, oh, these each have a different something. So the way R sees it is it's what. And this is the command to check it. R has different what's assigned to these. Class, yep, you got it. Yep, that's it. Great job right there. 50 points on the screen. They have different classes. So there's different classes depending on what we have. So if we go to alumni and type in class, it'll tell us that alumni is a data frame. Oh, there's no alumni. Did I delete it? Oh, it's movie. We haven't pulled in alumni. Alumni is a data frame. That's how R sees that. But what about if we go to class and we go to alumni $zip code? R sees that as a factor. And that's pretty good because zip code is not a numeric amount of zip code. Zip code is just different groups of individuals. So it makes sense. There's a lot of zip codes there. That can be problems for some algorithms. 29,400 different zip codes. And the vector, it's probably not a very clean. Hello, what's up, Ditto? Good to see you here. So we have right here to check how R sees something, which is the class of something, we can run class right here. And that's got it. I think there was another question on 9A for 474. Let's go check that out. We have just enough time to do that. 9A, new topic, 9A for 474. Let's go check out some 9A. How should we do the write-ups for the visualization assignments? Just talk like you're talking to somebody by being like, the median is the best measure of center because this data is very strongly skewed. The more words you use, the better. The more numbers you cite, the better. So make sure to cite numbers and cite kind of like what you're talking about. And especially, let me drop this in the chat. If you're working on visualization 2, I've got a video right here going over visualization 2, which should be a pretty good help. Also, if you have 9C, no worries. Oh, yeah. Let's go take a look at some 474. Let's go check it out. New topic right here, 474. And which one should we do, 9A or 9C? 9A or 9C? You pick first. Who picks? You're welcome right there, Peppermint Patty. And Python treats them differently for example objects. Yeah, and then Python uses... I don't know how Python does it. Python does it a little bit differently because it's object-oriented, right? It's not object-oriented. 9A votes are in for 9A. Imagine that a model is made that predicts the log 10 of the closing price of stocks. The numbers output from the model are this, 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 and this, and this. Print to the screen the untransformed values. So if something, I don't want to quite say, I'm not going to quite put it in here, but if something was logged 10, so if we took the log 10 of something, how do we undo a log 10? So think about this. If we have something that is log 10, like if I go here and do log 10 of 100, what's log 10 of 100? So I'm not quite doing it, but if we were to log 10 and core's right on there. So if we log 10 it, this is 2, but this will undo it. You can raise something right there and that undoes it. Notice how we just have the value of 100 because these two things right here are canceling. So if something's been log 10'd, we can just undo it. Yep, exactly. Raise it to the exponential of whatever it was logged to. So to undo a log, you have to take that and use the original values as the value in the exponential. So you're going to do 10 raised to that value. And so we take 10, and this is what 10 is then raised to, is whatever these values were. So log 10 of 100 is 2. To undo this, all we're basically doing is just canceling this out right here. Like these two things right here, they just destroy each other. So now with them existing, we still just get 100 because the inside and the outside are just fighting each other. So hopefully that explains that one a little bit. It doesn't quite do it, but it kind of does do it. Some algorithms require us to standardize things. So we wrote some important notes today. When we standardize, do I have those sets of notes? No, did I close the notes? That's such a bummer. When we standardize things, we can turn things into z-scores. So I don't want to quite say, but what functions do you need to turn things into z-scores? How do we find a z-score? Stat 1's going to be learning this very soon. How do we find, there's some z-scores right there. How do we find a z-score? A z-score is the observation minus the what? Over the what? How do we find a z-score? We take the value we observe, which can be a vector, because we can do vector operations. So we can take a vector, and then we do what? So we need to find, when you think about a z-score is just a distance of how far something is away from the mean, divided by in terms of standard deviations. Observation minus mean, exactly. So we're going to take the mean of this vector y, and then what are we going to do? Because that's the distance. All that is a distance. That just says, how far is an observation away from the mean of y? And if it's a vector, how far are these observations away from the mean of y? So that's just a distance. And so that's distance. Something can be above or below. But a z-score is a standardized distance. So we want to do observation minus mean over, and then we want to standardize it. Hence, standardize it. So we want to do observation minus mean over, and then what else? And then we'll have it. We'll have everything in z-scores. You can do, well, you're thinking about the formula, which I think I can write out. Well, yeah, I know what you're saying. You're doing the formula for this value right here. You're thinking about, I think I can write the formula for it. The formula you're thinking about is square root summation of, I so rarely have to write this, y minus y bar right here over n minus 1. I think that's it. And so a z-score is observation minus mean over what? And I think that's, oh, we do squared distance. What am I doing? Squared distance right there. There's some of the squared distances, and that's why we square root it. That should be right there. Observation minus mean over standard deviation. Generally written out a lot of times. We just usually abbreviate it with notation. We'll move this down here. That's we don't have to solve that. That's that's the formula for standard deviation, which we don't solve. Usually we just write it out like observation minus mean over standard deviation right here, or it could be written out with sample notation, observation minus sample mean minus or over sample standard deviation. All these are the same things. The top one is more the format if we're writing code, where we might have a vector of observations minus the mean of that vector divided by the standard deviation of that vector. Make sure to have comma NA remove equals true if you have NA values. But does this make sense, Cora? Good job. What is the code for standard deviation? SD. Lowercase SD, though. Lowercase. My S might look like it's capitalized. Cora, 50 points. Thank you for asking that right there. It might look like my S is capitalized, but it shouldn't be. You'll not get the right function. Lowercase s right there for standard deviation. So it's a harder one sometimes because it doesn't autocomplete. Anything that's under 3 letters, less than 3 letters will not autocomplete. I think I got a class here in 30 minutes. 20 minutes. Awesome. I'm going to pick up Morty here in a little bit. Whoa, it's been a busy day. Let's see. What other last questions do we have? We're on to our last questions. Oh, Vincent. You know what, Vincent? Here's some 50 points, Vincent. By the way, could a problem when you calculate standard deviation to all points and then split them into training and test and use S scores? Z scores or S scores? When you calculate the standard deviation to all points and then split them into the training and test to do like predictive modeling. Z scores. I mean, you could give it Z scores before doing that. Problem is if outliers were to go into like the training and test, because outliers, are going to drastically alter how Z scores are because they're going to inflate standard deviation or move the mean. So your Z scores just might look really weird. But if you have a large enough sample size and you have real random assignment, you should be good. Is the mean for 9C going to be 0 or really close? Look, it's probably super close. It's probably just that R is not carrying enough decimal precision. It'll probably be like E negative, something ridiculous. You're welcome, Vincent. Great job. Part C of 9. I think we just did that, right? Yeah, the negative 6 is. So basically what you have right there, Cora. Great question, Cora. 1, 2, 3, 4, you have like something like this. Like you have something like that. It's just R like carrying little dust over from each, and like it just R just for some reason can't do enough decimal precision carrying it all the way out on them, which is ridiculous. But it's just the computer's being honest, and it's like, oh, I've still got some change left over from not doing perfect calculations. Isn't that amazing? That, I mean, has to go do with like double decimal precision. You're welcome, Cora. Excellent work. I'll probably head off here in a moment. Gonna start teaching next class. Next class. Oh my gosh. Last class of the day. Day just flies by. I'm gonna get a snack here too. With that, everybody, we will be back. Puppet Shark and everybody says goodbye. Bye for now, everyone. I'll see everybody soon. Bye. Come by and visit anytime. See ya. Ah!